This is Technical Skills for Agile Development. If you're here for something else, you're in the wrong room, so sorry. You're welcome to get up and go there instead, wherever you intended to be. My name's Sam Taggart. Hopefully by this point, most of you know me. If not, you can go Google me, so something will come up. Well, actually, okay, I got a slide. This whole thing is just my well-informed opinion. I like to think I'm well-informed. I've been around for about 18 years. I run my own company. I've got a podcast. I've got the Consultant Summit. If you haven't been to it, if you're a LabVIEW consultant, it's awesome. We get together, we talk about business stuff. We got GDevCon NA, more content like this, less NI marketing, sorry NI. I've got a blog. I've got like 500 posts. There's probably something interesting in there, and all the other stuff. Some of the stuff I'm going to talk about is going to be a little controversial, so feel free to push back. But like all the stuff that we know about writing good software, there's no scientific studies. It's all just somebody's opinion. And you know, a bunch of experts have got, quote, experts have got together and agreed on some of this stuff, but there's still a lot of debate about some of these topics. So no hate mail, please. And how to get the most out of this presentation. So I'm going to present to you what I would call the modern software development set of technical skills. And it's a set of skills, and they all play together and play off of each other. So to get the most benefit out of it, you should be doing all these things. If you leave one or two out, you're not going to get the maximum benefit. But at the same time, don't let that feel overwhelming or whatever. All these things you can start implementing them incrementally. And you know, if you do one, you're not going to see a ton of benefit, but you do two or three, and all of a sudden it multiplies and you get a lot more benefit. So, all right. So everybody's probably seen this waterfall graph. I don't know if anybody actually truly does waterfall, but this is like the straw man that everybody puts up, where we do our requirements, our design, our build, our test, and deploy all as separate stages. And usually they're separate departments. And I have worked in places where they had separate departments for all of those things. And it's got problems. Right? If you've got separate departments doing each of those, you've got the handoff at each department, and people play the telephone game. You've played it as kids, right? Like the information does not always stay the same as it flows down the pipeline. There's a lot of passing the buck. Oh, our project failed. Well, I designed it correctly according to the requirements I was given. It's requirements' fault that they didn't gather all the requirements, or it's the builder, the software people's fault that they didn't build it exactly as I designed it, etc. And we get long feedback loops, and it kind of requires some kind of prediction because this whole process takes a long time, and we're making decisions at the requirements phase that maybe by the time we get to deploy, they don't make sense anymore. And it kind of ignores the fact that software is designed to be mutable and changeable, and this is kind of more of a rigid process. Anybody actually work in this way, or probably not, right?
I didn't work in that way when you were telling me I had to work that way.
Well, okay, yeah. But you were definitely told at one point to work that way, because that's what the bean counters thought it was all about, right? Yeah. The biggest problem with working in this way and not working in an iterative way is that it doesn't deal well with change. And the biggest problem is we're trying to plan on a time frame of months or years or quarters and not on a shorter time frame. And it has to do with certainty. So if I ask you all, what are you going to be doing 2 minutes from now? Hopefully, it's pretty predictable. You're all still going to be sitting here unless I scare somebody away, right? It's not 100% because somebody could pull the fire alarm and we're all running out the stairs. But there's not a lot of time for something to happen. If I ask you what you're doing next year, nobody can predict that because there's so much time and there's so many things that could happen in between. So the shorter time frame we plan on, the more predictable we can be. Doesn't mean like things don't happen or whatever, but there's a higher chance that our plans actually work out the way we intended. And so Agile isn't about getting rid of any of these phases or anything. It's about taking them and taking our project in small chunks and putting them in a circle and doing those things continuously. So we pick one or two requirements or features that we want to build. We do a little bit of design work. We write some code. We test that code. We deploy it. We get some feedback. We look at our list of requirements again. We pick the next one based on our priorities, which we can change, and we do it all over again. Anybody working that way or roughly that way? Hopefully. Anybody working a completely different way? Because not everybody raised their hand. So anybody want to talk about how they work in a different type of manner? Okay.
In a panic mode.
Panic mode. Okay, yeah, there is the firefighting mode. There is the run around with chicken with your head cut off. That's not a plan.
It is a work style.
It is a work style, yeah. It is a way of working, as Jörg would say. I don't recommend that. I have done that, but if you're doing firefighting, fire prevention is a much better profession. So all this Agile stuff has an effect on the way we organize our companies and our teams and the way we manage projects. And if you read all the Agile stuff, they talk about self-organizing teams and people over process. And there's a lot of getting rid of silos. How many people work in really siloed organizations? I'm sure some people, right? They happen, right? Nobody likes them, but they still happen. And so instead of silos, we tend to have a team per project, like that cross-functional team. Instead of having the QA department, you have a team and they have a QA person with them and they have some software developers and some other UI people and they all work together. At least that's the ideal. And it's a dramatic way to change the way we manage software projects because we're trying to push the decision towards the information. So ideally, if your software developers are talking to your customer, how many of you are software developers and actually talk to your customers regularly? Okay, I should see a lot of hands. If you don't, you're missing out because there's a lot of information there. And so you make better decisions when you have more information. And so if your engineers who are writing the code are the ones talking to the customers, they have the most information. They're gonna make the best decisions. But in the old school model, the customer asks for something, I can't make that decision. I gotta talk to my manager, who talks to their manager, it bubbles up to somebody who can make a decision and it bubbles back down. And you have the same telephone game and finger pointing and all of that, right? So we wanna get rid of that. I'm not an organizational psychologist. I can't help you fix that. There's a whole set of people, and I know people who do this, and I'm happy to refer you to them. I can commiserate, and I can possibly point you in the right direction, but that's not the whole story, right? So part of Agile is changing the way we think about projects, and actually even the word project, right? How many product versus project? Anybody hear that distinction? Anybody want to talk about what that is? Why don't you tell me, Alan?
Yes, if I do how.
Oh, okay. Do you want to talk about product versus project? Oh, what?
I'm the mic runner.
Oh, okay, cool. You're fine. Anyway, so people talk about project management, right? And a project has a start date and an end date. How many people think software is written once and then just left alone? There probably are some applications where that happens. Whoa, that got really loud. There probably are some applications where that happens, but I would argue most of them, no. Yes?
Actually, I will make a product versus project.
Because I was actually talking with Greg Richardson about this at the Champions Dinner. A major distinction is that I have found that on project work, the customer is often willing to accept work that would be considered incomplete in a product because a product has more finish to it, and the customer on my projects is like, well, I don't need that polish. I don't necessarily need perfect error handling for my off nominal situations. We're okay because they don't want to pay for that.
You're
right?
using a different meaning of the term product. So you're thinking product as in something internal that I use for myself versus a product is something I sell to people. Okay, and in that sense, you're completely right. But
well,
product versus
LabVIEW,
project.
we were talking LabVIEW versus what I deliver to customers that I've built in LabVIEW as an example.
Yeah. Okay, yeah. So when I'm talking project versus product, I'm talking like project management versus product management. LabVIEW is a product. It's not a project. They didn't spend 6 months on it and then they finished it and they shipped it out and they're done, right? Now in the old days though, they did kind of probably have a project mindset. We're shipping LabVIEW 2, we're shipping LabVIEW 3, we're shipping LabVIEW 3 or LabVIEW 4. But you've noticed that NI has changed, right? Now they're just updating quarterly and they're adding features, but they're not redesigning the projects. It's now a whole new thing. It's more incremental. Does that make sense to people? Any big questions? It's more of a long-term mindset and understanding that software has maintenance and we have to continue to add features to it and to grow and adapt. So here's some good reading. I don't know if anybody's read either of these books. I know Fab recommends the Agile Samurai. Great book, geared towards developers. This is where I got the idea for technical skills for Agile development. The Agile, there's some project planning thing in there that's really awesome. That project kickoff thing that's really good. I forget what the name of it is off the top of my head. And then there's a book, The Nature of Software Development, which is more for leaders, more for CTOs. But they both kind of talk about how all these things fit together and very much the inspiration for this talk. And you'll see a bunch more books as we go along. I don't have links for those, but you can find them. They're pretty popular books. Go search on Amazon. So these are the technical skills. The Agile Samurai had 4. I added a couple. First foundational thing is get and versioning. And I don't mean just using Git, but I mean like displaying the version on the screen of your thing so that when the customer complains, you can link it directly back to a specific commit. And setting up a system so that that is always true. Not just sometimes true, but always true. And this goes for RT and FPGA code too. I don't do a lot of that, but you need to have a way to get the version out of that. The next one is automated testing, test-driven development, refactoring. The next one is kind of controversial, but I'm a big fan of trunk-based development and software teaming. We'll talk about that. And continuous integration and continuous delivery. Hopefully everybody's at least somewhat familiar with those. We're going to go into detail on them all. Anybody not heard of any of those? Any of those like new? Yeah, which one's new?
Everything.
Okay, cool. Hey, everybody starts somewhere. Good, you're in the right presentation. You're going to learn a ton. Anybody else? All right, so the first thing, I run a podcast called the LabVIEW Experiment. I like experimenting. By the way, if you haven't seen the podcast, go do it. I'm surprised at how many people don't know about it. I ran into a bunch of people, so go listen. It's good stuff. But we want to encourage our developers to experiment, to try new things, right? And that brings problems, except that Git gives us the freedom to make changes. If I have my code in Git, I can change anything I want. If it doesn't work, I just press one button and it goes back. Super easy. If you're not using it, you should be. If you're using SVN, I will say Git has a lot of advantages, and I highly recommend you switch to Git, but it's better than nothing, and either way, you definitely want to be using source code control. Git also allows us to coordinate. A lot of people like to have multiple people working in parallel and do this pull request stuff. I don't like that for my own reasons, and we'll talk about that, but if you insist on doing that, Git gives you the ability to coordinate all that. Git also helps you find bugs. And Chris Roebuck, how many people read Chris Roebuck's presentation? All right, so say you have your code, you test it, it works great. You make 100 changes, and all of a sudden you decide, I'm gonna run the test and something breaks. How much of a pain is that to debug? Right, you gotta search through 100 commits. What if you made one commit and the test automatically ran and said, oh, you made a mistake? You think that's easier to figure it out? And then you look and Git and it says you changed 2 files? Well, holy heck, 2 files, that's easy. And if you make small enough commits, you don't even have to debug. You can just say, throw those away, go do it again. One of the biggest things about working this way, I spend very little time debugging. I spend almost no time debugging code that I wrote. Sometimes, like a customer will report an issue out in the field and then I spend time debugging it, but like in my cycle, if I'm writing some code and I have a bug, I look at it for 30 seconds, I can't figure it out, throw it away and Git, try again. And I lose 5 minutes of work, and it is amazing and freeing, and I highly recommend everybody try it. Here's some further reading on that. This Git for Teams book is really great. It starts with workflows, and it says, here are some possible workflows, and it gives you some ideas, and then it backs into, here's the workflow, here are the Git commands to do it, and here's how you teach your team how to do it. So if you're on a team, awesome book. The version control with Git book is super nerdy, super low level, but if you read that, you will understand how Git works behind the hood. You'll probably understand more than you ever wanted to know. I will throw in a plug there. I have a Using Git Effectively. I think Alan's went through some of the stuff, some other people have. It's really good. It's hand-on, bunch of videos.
Yeah. Sam's course is good. Backed up with Git for Teams is a good combination.
Yep.
I learned a lot.
Yeah, I feel like the right approach is somewhere in between there, because you have to think about the workflow, but also having an understanding of what's going on under the hood just a little bit really helps. I feel like most developers, particularly LabVIEW developers, how many people just know 2 or 3 magic incantations that you type into Git and that's it, and when it goes off the rails, you're just like, I don't know what to do. Come on, somebody's got to be honest. There you go. Thank you, Mark. That was me for a long time, and then I read these books and I was like, okay, now I understand why this or that happens. Or like, how many people know what a detached head is? Doesn't that sound scary, right? Like, who wants to have their head cut off, right? It's really not all that scary, but it happens very easily in Git if you're not careful, and if you don't know what it means, you panic, you're like, oh my God, my head's missing. Like I'm a Kabod crane or something. All right, so we want to deliver working software. How do we actually know that our software works? Right? And we want to do this every iteration. So every time we add a new feature or something, we want to make sure it works. Because again, we don't want to end up in that situation where we add 100 features and then we have to sort through them all to figure out which one broke something. In the waterfall world, typically, if we have a separate testing function at the end, and we do this giant site acceptance test, factory acceptance test, and some of you may be required to do that no matter what, and hey, fine. I'm not telling you not to do that. But we need to figure out this problem of every time I add a feature, I still want to test my code. So the problem with the SAT and FAT stuff, they're very high level tests. So I toggle this input over here and this output over here is supposed to toggle. It doesn't. How many possible things go wrong? Well, is it wired correctly? Is it in the correct channel? Am I reading the correct channel? Is it getting passed around the correct way in the database or inside my program? What other signals feed into that? Is it the output? Is it the wiring? Right? There's a whole bunch of problems. Like, it's great at telling you there's problems. It's horrible for diagnosing them. It requires the entire software package to run usually, because usually it's end-to-end testing. It requires the hardware. How many people write code for hardware that they don't have yet? Happens all the time, right? They're going to ship you the stuff and you're like, well, I want to write the software now. Do I want to wait until I get the hardware to see if my code is actually doing what I think it's supposed to do? Right? So can we do some testing before that? And it's time consuming. A typical site acceptance test, factory acceptance test at Westinghouse was 2-3 weeks. If I'm going to iterate and produce code every week, I can't spend 2 weeks testing. It doesn't work. So that's where unit tests come in. You take chunks of your code, and I kind of refer to it as pulling the Lego blocks off your code and testing each Lego block and making sure they're good. So they run really quickly. They're isolated, which means that you can pinpoint bugs easily, because when something breaks, it's in that chunk of code. It's not anything else it could be. They work great as regression tests. And there's a whole bunch of benefits. I pointed out that I have a blog. I have like 50 articles on all the benefits of unit tests. You can go look that up if you really want. So here's 2 books. If you're new to unit testing, the one on the right is better. It's shorter, and it's a little bit easier and lower level and easier to understand. The one on the left is actually really great if you're managing a giant project and you get hundreds of tests. Because there are projects where you've got a lot of code and you end up with tons of tests, and test time becomes an issue and managing the tests becomes an issue. And that book on the left is really good at that. I will tell you, I'll warn you because nobody warned me, that book is 600 pages. I ordered it because Nancy told me to get it, and I got this box and I couldn't pick it up. It was like a brick. And it's like, it reads pretty quick, but yes.
Any book on LabVIEW unit testing?
There is actually a book on LabVIEW unit testing. I don't know why I didn't include that. Fabiola's book, which is what, LabVIEW graphical programming?
Yeah. It's like LabVIEW graphical programming for everyone, or it's that one?
5th edition.
5th edition. It has to be Fabiola. Look for Fabiola as an author.
Yeah, and her book's actually really nice. It doesn't go into super detail on unit tests, but it does pick out several different frameworks. It shows you how it works in each framework. So yes, I probably should have included that. I just kind of maybe assumed that people already knew that, but yes, very good point. I will add that to the next edition.
So you did not use this book since you said like it's you. Let's say I want to start.
I'll make you repeat it. So
Hold on, yeah, please repeat it because I couldn't hear it anyway.
So I'm just curious to know, because I was interested in this book, but you started saying it's huge, and after that you did not continue. So my question is, did you ever use this book? Or
I actually did read it, and I think it's got good content, but it's geared more towards managing large numbers of tests. If you're just looking to get started with unit testing, do the art of unit testing. And this one has examples in C#, and I think there's some with examples in other languages as well. And I think there's a newer edition too. That's the 2nd edition. So there might be, if you know Python, there might be one with examples in Python or something. Oh. And actually, that was something that I did not mention for those of you who are in the Python versus LabVIEW thing. One advantage to knowing a little bit of Python or some text-based language is if you read computer science books, there are very few computer science books written in LabVIEW. So understanding a little bit of text-based programming makes it a little bit easier to pick up some of those computer science
Or
things.
it's an opportunity for some of you to write a book.
I'm looking for co-authors. You do all the work, I take all the credit. Oops. All right, anybody ever heard that acronym BDUF? Okay. What does it mean, Alan?
Big design up front.
Yeah. So I honestly used to be a big proponent of this. When I worked at Westinghouse, I was like, you just do the design up front, you get everything perfect, and then you write the code. Writing the code's easy. And that can work if nothing changes from the time you do your design until you think, and it's a very straightforward project. But it's kind of arrogant. Yeah, I was a little arrogant. It assumes we know all the requirements up front. So it assumes that the customer knows the requirements up front and that they can actually convey them to us, which is challenging. How many people have customers who say, I'll know it when I see it? Come on, I've definitely heard that from people, right? Especially, I do a lot of R&D stuff. They really don't know what they want. They have an idea, but they have no clue. It's prescriptive and rigid. How many people have gotten to near the end of a project and you've got a large percentage of the features done, but there's like 1 or 2 that aren't done and you're all worried about it, and they're like, don't worry about that. We don't need that. Definitely has happened sometimes, right? So I feel like doing the big design up front requires us to gather all the requirements up front. The customer looks at that and says, well, this is our chance to get everything in, so we're going to throw everything we could possibly want in there, including the kitchen sink. And they don't really need it all. And generally, it's like the 80-20 rule, like 20% of the things provide 80% of the value or whatever it is. So like there's a lot of stuff in there that if we don't get to it, probably okay. It could probably be pushed off to round 2. Again, it depends on what type of industry you're in, right? Highly regulated industries, you might have a different take on this. That goes back to the, this is my opinion and highly specialized. Test-driven development. Anybody know, who's heard of test-driven development before? Cool. So yeah, it's this idea that you write the test first. So you write a test. So you decide you're going to add this feature. What I typically do is create a list of tests. So here's this feature. Here's the 10 things I'm going to test. I pick one of the things I'm going to test. I write a test for it. That's the red phase because the test fails and usually it pops up a big red banner. And then you write some code and you make the test pass. And part of the idea is to get to that test passing thing as quickly as possible. And usually the first pass, there's nothing to refactor. And I do that a few times. And eventually I end up with this soup of code. And I look down and I'm like, well, that kind of looks like the factory pattern or the template pattern or some other pattern. And then I do this refactoring thing where magically I transform the code, which we'll talk about in a minute, how we do that. And now I've got a factory pattern and then I keep going. I think it works really well for design. It avoids building unnecessary features. I think I'm going to need this, but then I never need it. So this helps me to build just what I need. There are a couple challenges. One thing I would say is you can be too myopic. So if you're just like trying to do the local optimization, you have to take a step back and look at the bigger picture and make sure that what you're doing fits into the big picture and makes the big picture better. The other mistake people make is they skip the refactoring step. They just get into this, I'm going to write a test to make it pass, write a test to make it pass, and they end up with this soup, and then they never clean up the soup, and then it's just a mess. So don't do that. Do take some time to do some refactoring. And bang for your buck, refactoring is, unit testing and refactoring are the 2 biggest skills you can learn that will improve your LabVIEW development. You will get the most mileage out of those, and they're the easiest to learn. And there's a book. Kent Beck wrote a book. Kent Beck's awesome guy, super smart, great book. There's only one book there because he's like the guy. So yeah, you guys will all have access to this later, but feel free to take pictures. If I move too fast, I can always go back. Got your picture? All right, so I mentioned agility, right? The word agile means like changing direction quickly. Well, how do we actually change direction? Well, the first thing is we have to recognize that we need to change direction. So in this agile process, we're doing our iterations at the end of every iteration. We do a demo. We show the customer our software. We get feedback. And we also do retrospectives. How many people do retrospectives? If you're not, you're missing out. It's the best form of feedback you can get. At the end of every, you're doing a pair programming session. At the end, 5 minutes. Just stop, say, how did that go? What did you think? What worked well? What didn't? At the end of every iteration, ask your customer, how did this go for you? What could we do better? You're missing out on tons of information and feedback. And then also at the start of every sprint or whatever you want to call them, iteration, we do this planning prioritization thing. So we finish one feature. We could just pull the next one off the list, but I always check in with the customer and say, hey, here's the next thing on the list. Is that the most important thing to do now? Is there something else that we should do first? And you have that conversation. And sometimes you're driving the priority, sometimes they are. So sometimes it's what's most important to them. Sometimes there's something that's really important to them, but you're like, hey, yeah, it'll be easier if we do this other thing first. Or maybe you're driving it and you're like, this thing is a high technical risk. I'm not sure we can do this. Let's move that up the list so that we figure that out right now. And if we can't do it, let's cancel the project. No sense in spending a bunch of money if it's not going to work. So that's also an important part. That's more of like the project management stuff, but it's also important. But refactoring, this is how we really change direction in the test. How many people do refactoring regularly? What do the rest of you do? Do you just throw away your code and write it over? I'm saying that somewhat facetiously. But, right, so, right, the refactoring thing is we have code, it's in Git, everything's good. We look at it, we're like, that's not the best way to do that. So we make a small change, run our tests again, hopefully you have tests, and then we do that. And it's really, refactoring is about taking a series of small steps. It's not like, if you just take your code and you just delete a whole bunch of it and then rewrite a bunch of it, that's not really refactoring. Right? It's small steps towards where you want to go. And it's a collection of small steps. Kent Beck has this quote, for each desired change, make the change easy. That is the hard part, not warning it, maybe it is. And then make the change easy. So basically what Kent Beck is saying, so there's refactoring like the TDD cycle, but here he's saying, if you have a feature you want to add to your code, so I have code, I want to add this feature to it. Take a step back and think to yourself, well, what would be the easiest way to add this feature? So I have something that has a DMM in it, and it's a key one, and I want to replace it with an NI one. Well, in an ideal world, what would be the easiest way to do that? Well, it'd be really cool if I had a hardware plugin layer and I could just drop an NI-DMM driver in the right thing and it would work, right? That might be the easiest way. Or maybe it's I change an INI file, or whatever that is. You figure out how would I like this thing to work, and then you take your existing code without adding the new DMM or anything, and you change it to make that possible. So you refactor your code to use some kind of class hierarchy, right? You inject the parent class and all that, and you set up to load your existing DMM from disk, and then you test that, and you make sure that, hey, that works with the old code. I haven't changed the functionality. Oh, that's the other key. Refactoring is about treating your code like a black box, and you're not adding functionality. You're just rearranging the pieces inside the black box. And at the end of the day, somebody looking at it from the outside can't tell the difference. And then once you do that, then it's really easy to take that NI-DMM driver, wrap it in a class, and drop it in the correct folder, and it all works. And it leaves your code in a better state. And then when you need to add a third DMM driver, super easy, just drop it in the folder again. Does that make sense? How many people actually work this way? That would be some of you. Sometimes. How many people have ever worked this way? Anybody ever worked that way? Okay. So we do it sometimes, right? When it's really painful if we don't, right? Because sometimes, the boss goes and says, I want you to add this. And you look at the code, you're like, there's no way I can add it the way it is, right? Like, it's just not going to happen. And you have to do that refactoring. And hopefully, you do the refactoring steps where you're doing these small changes and you do it away. Because really, the small change stuff is about risk. So, as an example, you want to make that change to your code. If you do all of that in one step, the chance of you making a mistake is high. And then you have a bunch of changes to sort through in order to figure out what broke it. If you do one step at a time, you break this step. Okay, I forgot to, I put something in the wrong case structure or whatever. I can go change that and fix that, and that's easy. So it's about not spending time in the debugger, because the debugger is a time suck. You do not want to spend time debugging if you don't have to. So it's a lot easier if your debugging is, I changed one VI, the problem must be in that VI. I look at it, okay, I know what the problem is, I fix it. That is 90% of my debugging. If you're there and you've got 20 VIs open, you got breakpoints everywhere, like you're doing something wrong. Like sometimes that you have to do that, but if you're doing that all the time, you need to fix your process. And that's me trying to be kind to you, not like beating you up, by the way. There is a book called Refactoring by Martin Fowler. I read the first edition. This is the second edition. I think in the second one, all the examples are in JavaScript. But there's a website that goes along with that. It lists a bunch of code smells too. So the thing about deciding when we need to change direction, there's this idea of code smells of like things that you should see in your code that might make you go, ew, maybe I should change that. One might be if you have DVI, right? The giant VI that doesn't fit on the screen, or if you got one where there's no white space, or maybe something where like, hey, there's a stacked sequence structure that's 17 frames deep. Probably change that. Or a bunch of nested case structures or whatever it happens to be. There's certain things, and I think we probably all have some of those things that we see it where it's like, yeah, that's a bad idea. All right. This is probably the more controversial part, so if you don't like it, sorry, I feel free to ignore the advice. But are we actually working together? So if you think about it, if you're a basketball coach, right, there are certain things that have to happen, and I'm not a basketball player, so this analogy might fall flat, but if you're a basketball coach, you got to do rebounds and free throws and block shots, right? You've got your top three priorities. You don't hand each one of your players a basketball and a hoop and say, you go off and go do that, you go do that, you go do that, and expect to actually win the game, because that's just not the way it works, right? How many of us work on teams where we have our weekly sprint meeting or whatever, planning meeting, and you go work on that branch of code and go do your thing over there. You go work on your branch of code and do that thing over there. And you go, anybody do that? Come on, some people have to do that. Lots of teams work that way. It works. Teams make it work. But it's not really, I wouldn't call those people a team. I would call them a group of individuals. And I think if you can work together as a team, you'll get better results. Not saying you have to do it all the time, but if you're not doing it, I highly recommend that you consider doing it. And we think that people running in parallel are faster because they're unencumbered. They don't have to wait for anybody. They can just go sprint ahead. The problem is you still have the coordination. You still have to get everybody on the same page. You still have to merge everything back in, and there's some costs there that are kind of hidden. There's a guy, Dragan Stepanovic. This is really interesting. This came out like a few years ago. And there's the engineering room is Dave Farley. He's the guy who wrote the continuous delivery book. Lots of good technical content there. But basically, this guy, Dragan Stepanovic, he's a consultant. He analyzed 40,000 pull requests over 2 years. And he looked at what's the ideal size of a pull request? Because we know if you ask somebody to review a piece of code, depending on the larger the code is, if they ask you to review 200 VIs, you're not going to do as good a job as if they ask you to review 20 VIs. If they ask you to review 1 VI, you might also just quickly go. So there's an ideal size. And basically, he analyzed all of it and did all the math and figured out that basically pair programming was the most efficient way to do it, to not actually do pull requests at all. And just, some people do the pull requesting because we have to have 2 sets of eyes on the code, right? That's a reasonable requirement. One person writes it, the other person reviews it. But if you got the 2 people working together and looking at it the entire time, is that good enough? I would argue yes, but I don't know. If you work in a highly regulated industry, you might come to a different conclusion. I don't know. But anyway, it's interesting and it's worth looking at and investigating that. And Dave, if you haven't watched Dave's videos, he's very scientific about it. He is a little bit dogmatic for me, which for me to say that is I can sometimes be a little dogmatic. So, but I will posit this last couple thoughts on working together like this. What do people do for onboarding? How many people, when you onboard a new person, do you throw them in a room by themselves and tell them to figure it out? They probably don't stick around if you do that. But you put them next to an experienced person, right? And they tag along and they watch and they work together on stuff. That's pair programming. What do you do when you have an emergency? How many people throw 4 or 5 people together in one room or one computer and say, you guys sit down and don't leave the room till you figure it out? That's mob programming. We inherently do these things already. And yet when I say let's do them normally, people are like, oh no, we can't do that. We can't. It's too wasteful. Why? If we can do it there and we can do it here, we could do it more often. Again, not saying you have to do it all the time. Some people absolutely hate the idea of pair programming. Some people are very antisocial or have social anxiety or whatever. If it doesn't work for you, that's fine. But I think you'll have better results if you can do this. And the biggest one, it solves the lottery problem. Again, I may have said this in one of my earlier presentations, but if you got a guy, Bob, who's the database guy, and he's the only buddy who touches the database, and he wins the lottery, well, good for him, but you've got a really big problem. Right? Because you got to figure out how to do the database. Now, nobody knows how. But if Bob occasionally pairs with Susie, and now Susie has some idea how the database works, you're okay. So I highly recommend people consider it and give it more thought. I feel like in the LabVIEW community, we don't give it enough thought. There is a book, Software to You. So all the books, this is the one that I haven't actually read, but it is the book on it. I have taken some classes from Woody. He's really good. And in fact, if you follow Woody on LinkedIn, he often gives free courses on working together in teams and mob programming and stuff. They're free 1-2 hour Zoom courses, totally worth an hour of your time. Even if you don't work in a team, it's still it's fun. It's a good time. You learn a lot. Very bright guy, lots of experience. Is that the last one? I sort of have, maybe it is the last one. Oh, let's release some code. Okay, I thought we had more. All right, so now we want to be able to actually release our code at the end of our iteration. Why do we want to release our code at the end of our iteration? Because we want to get feedback from our customers early. So the best feedback you can get is to get your code in the hands of your customers. Because even if you did everything right and you designed just the way you wanted, that might not have been what they meant. But when they see it, they'll know. So you hand them something, they're like, that's not what we meant. Or it'll spark a new idea, but like, hey, it's kind of cool that we can plot that. Maybe can we plot this other thing? And maybe that becomes the new next most important thing to do. And really, releasing often is about smaller features more often. Anybody ever hear the term vertical slicing? So if you think of your code as like layers, right? You got the hardware layer, you've got the data manipulation layer, you got a presentation layer, maybe you got a storage layer, and they're like horizontal, right? Vertical slicing is taking a slice of the cake vertically and hitting all those layers. So anybody ever hear the term walking skeleton? All right, so often people build their code, they write all the hardware drivers, then you write all the data to collect it and data and store in a file, and then you write all the layer to do the GUI stuff. But what I tend to do is do a vertical skeleton. So I'll have like one GUI graph, one piece of hardware, connect it to the file, and I'll just have that. So I'm like logging one channel and displaying one channel. Right, so that's the walking skeleton. And I get that up, I get it running, I make sure it builds, I make sure I can deploy it. Right, because how many people have ever done a project where you wait until the end to build or deploy and it doesn't work? Right, I see here, yeah, everybody's done that at least once because you have to learn that lesson. Right, yeah. So here's a story. I had a team that I was working with. They're in India. And they had a 3-hour build time. And they were building regularly. They were doing that part. But they were not actually running it. And they went a year without actually like running the build thing. They're just like, oh, it built. Okay, good. Yeah, I know. Some of you are looking like crazy. But this is what they did. And then they found out that the build wouldn't run because it was an actor framework project. And something was loading a DLL. And it couldn't find the DLL. But they had 100 different pieces of hardware that all, and they could not figure. 3-hour turnaround time. So every day you come into the office, you make one change, you wait 3 hours, you check it, you make another change, you wait 3 hours, you make another change, you go home. And it took them like 2 or 3 months to figure out which one it was that was, they had several actually that were missing DLLs. So like they tried the whole binary search thing, and at some point they're like, well, both tabs have problems. Now what do we do? So this stuff is really important to be able to do this. And I know some people like Gitflow. I know George's probably not here. He will bash me over the head with Gitflow. But if you're going to do that, make your feature branches short-lived. Anybody ever make a branch that lasted like longer than like 2 weeks? How many of those actually ever get merged back in?
We had a regular merge process for it. We just had, each developer had a branch.
But then you were merging it back in. You didn't wait 2 weeks to merge, right? Yeah, I remember when I worked at Westinghouse, like, oh, we need you to fix this thing. Go over there and go do it. And I spent a month, made it look beautiful. Pushed it back in. They're like, no, can't do that. Breaks too many things. And they just threw it away. And I was like, really? A month's worth of work? Like, yeah, that was it. So partially my fault for not realizing that, but hey, you gotta learn somehow. I will say continuous integration automation, we tend to think of those as synonyms, and they kind of related, but continuous integration is more the mindset of, I'm going to integrate my code regularly so I don't wait 2 weeks and then find out it doesn't work. Automation helps us do that because automation is about having robust procedures for the merging and testing. Because if we're going to do all these merges all the time and we want to make sure they work, I don't want to run manual tests all the time. I'd rather it's automated. I make a push to get and I just forget about it. So like the way I do is my server runs a test and it pings me. So I'm working, I make a push, I'm like, okay, I go start on the next thing. If I hear a ping, I'm like, oh crap, because my email pings me and says, oh, it failed. So, yeah. There's a book, Dave Farley, some guy from the engineering room or whatever it is. Continuous Delivery, good book. Maybe not the easiest reading, slightly computer sciencey, but it's still good. All right, so some of you guys are like, yeah, I can figure all this out on my own. You all are probably smart enough to figure all this out on your own and go read all those books and figure all that out. But it's hard. There's lots of moving pieces. There's not like you just read one book and you suddenly figure it out. You got to piece together all these maps, and it takes a lot of time. And I equate it to like wandering through a cave in the dark. You're going to stub your toes and you're going to trip and fall and all those things. So if you happen to want a guide and somebody to hold a light and tell you where you're going to stub your toes and like step over this and duck under that, I am happy to help you out. We run some workshops. We do pre-record online classes. We have a mastermind group. And actually, I did not include, I do have, there's a website, I put it on my other one. And I'll make sure I give it to you somewhere. But there's SAS GCLI tools. I have a whole bunch of CLI tools for automating stuff. I have a whole website about it. It's free. go look at it. It's got all the information you'd ever need to set up CI/CD. But again, it's the same thing. There's a bunch of moving parts. It's a pain in the butt to set up, and it will take you a while, and you're going to stub your toes. So any questions, comments? I have no idea how we're doing on time. I think we're about right. I'm happy to hang out even when time expires or whatever to answer questions. People have questions. Did this resonate with anyone? Like, make sense?
Sam, so question, like, so I do unit tests for, like, you write a library code or you have a class or an actor or something, and you have a unit test and everything's great, but then I'm missing the next level up of, like, the integration testing that happens automatically. Like, how does anyone do that? Like, like as soon as you bring the GUI in, like, it just all falls down. Like to automate that as well.
So yes, you can automate integration tests with the same tools that you use to automate unit tests. Like, it doesn't care what size the test is. Integrating stuff like GUIs and hardware, there's this idea called the humble object. And I don't know, like, if you Google it, I think you'll see the pattern, and there's other names. But basically what you want to do is separate the stuff that gets presented to the user from all the logic. So, like, logic is easy to test. GUI stuff is hard to test. Hardware is hard to test, but logic is easy. So for example, if you have, like, something that sends serial commands to an instrument, right? You can pass in a number and have it all formatted inside the VI that calls the serial stuff, or you can put all the logic for formatting the command into its own sub VI and test that. So you can make sure that you're sending the right string across, but you can't necessarily verify that you're getting the right response, but there's ways to do that. For, like, GUI stuff, right? If it takes a graph, you got something where you pass an array of data into a GUI and it shows a graph, but it also calculates a bunch of stuff. Move those calculations into a sub VI and you can test all those calculations. So you're not going to get everything, but you can get a lot. There's also several programs for doing GUI testing. There's Selenium, there's AutoIT, there's PyAutoGUI. I haven't had luck with any of them, but the one I've heard the best about is AutoIT or AutoIT. It's a Windows thing. It lets you, like, simulate mouse clicks and stuff like that. I would look at that.
I mean, I'm just curious, does
hardware,
anybody do that? Like actually doing the automated integration testing? It feels like that's always a manual thing.
You can also, with some of the CI/CD stuff, GitLab lets you run your own runners. So you could have a runner that's actually hooked up to some hardware if you really wanted to. You could have a PXI chassis with a bunch of instruments hooked up to it, and you could have a runner on there that will download your code and run some tests. You got to figure out how to control the hardware in your tests, but in theory, you could do that.
I have done some because, the customer insisted, and the way the software had come together is we really had to write basically the unit test that called the whole stack or almost the whole stack. So we would inject the command at the start of the chain and let everything run until we had something come back. It can be hard to put that together because you can have a lot of complex interactions. You need less of that if your unit testing is more comprehensive and you've done a good job of modularizing your code.
There's also an article about that by a guy named JB Rainsberger that says that basically this type of tests are a scam. And part of the problem is when that breaks, it's really hard to figure out what broke. It's good at telling you something broke. It's hard for the debugging part. Whereas if you had more robust unit tests and you caught that, like, there's some things that are just interactions between two things and you can't catch it. But
yeah, that's actually one of the things that I really like about using classes in LabVIEW is that I can, those intermediate layers that are what you're often testing when you're doing your integration test. If you've set it up so you can inject a mock object or a redirector or something like that for the lower level, I'm calling hardware. Well, instead of actually calling hardware, I call something that just redirects and sends a message that I called the hardware. And you can do that at every layer. So you can test every layer of a feature independently. And if you've done that separation right, when you put it together, 95, 98% of the time it works and you don't have to have a test. Not always.
Can I put in a plug for LMOC? Anton Sundquist. He's Finnish. He has a LUnit framework and it has an LMOC that lets you mock stuff really, really easily. So if you're doing that type of stuff, it makes it trivial.
Yeah, one example of integration is you mentioned it with the real hardware for performance assessment. So you cannot simulate the logic, but when you run on your hardware device, you test that loops works in a certain time, and stuff you cannot anticipate. So in my case, the continuous integration is going to the hardware and testing if the time is respected or other things.
Yeah, you can do some of that stuff. You can also, in a lot of the CI/CD things, you could do manual tests. So you could have like, there's a manual test, and you can even have the manual test download the code onto the test thing and be like, okay, it's on the manual test, the bench or whatever. Someone has to go over and manually run the test and then go back to GitLab and click OK and say, yes, it passed, or no, it failed. So you can do things like that.
And I was going to say, for UIs, find that user. Every company has someone who can be that user who like clicks and does things weird, and you're like, why on earth? So honestly, I tend to build the UI as a separate layer, and I'll find one of our interns or co-ops, and I'm like, just poke around. Here's what it's supposed to do. Watch them. Sit and watch that user. It's not an automated unit test, but it is a good test for your code, because however my brain works usually doesn't work the way most people does, I think.
Yeah, automated unit test does not mean don't do any other testing, but like automate as much as you can and catch as much as you can with the automated tests, and your life will be easier. Wow, I left everybody speechless. Woohoo! All right, I think we're done. I'm happy to hang around.